Hello and welcome to our rock, paper, scissors video. Here we're going to be explaining our rock, paper, scissors machine that we have created and kind of run you through what we did with this.
Rock, paper, scissors box. Here are the three inputs, rock, paper, and scissors, and here's our difficulty LED. The difficulty LED will flash different colors, blue, green, or red, depending on how easy, normal, or hard it is. And then here's the display. As you can see, it's going through its settings. These are the human scores, and then this is the computer score. So the human's going to choose rock first, and then it's on easy mode. And then the computer chose scissors, so the human won. Next we're going to choose paper, and so the computer chose rock, so the human won again. And then next we're going to choose scissors, so the computer chose rock, so the computer won that time. Next paper, and then human won, so it resets and then we restart again. Let's put it on hard mode, and let's choose rock first. So the LED is red, so it means hard, and that's a tie, so they both light up. Let's choose paper next. That's a tie again, that's interesting. And then scissors. Okay, computer won that time. Paper. It's a tie, and computer won that one. Let's choose scissors. That's a tie. Oh, humans actually won that one. Then paper. 2-2, humans, computer. And then the computer just won that one, so resets and goodbye again.
And another thing is we use the serial monitor to have some feedback, so it'll prompt you to say, hey, it'd be great if you choose a difficulty right now, and it'll let you know if you won, so you're not completely dependent on the lights to know what's happening.
Rock, paper, scissors game is powered by a Raven board, which here at George Fox is very similar to a Arduino Uno, and we have three perf boards going on here. This top one up here, as you can see for the LEDs, underneath it we just have two different individual resistors. It's pretty hard to see that connect it, so the pins are active high, so when pin turns on it runs current through there, and then the ground, of course. And on this one over here, this is the difficulty LED. That's just four main parts of an RGB LED: red, green, blue, and ground. And then down here is our button, which is actually pretty interesting. We have a 330K resistor at the very bottom towards ground, and so when you press a button, as you can see here, the current takes three different paths, and so thus producing three different currents that we can then calculate with these buttons. So when you push one button, it'll go through one path, and then the next button, and the next button. So there's a difference there that we can really tell and use our code to manipulate.
So the final part we have to explain to you is our code, and while I would show it to you, the resolution of my camera is really terrible, and that wouldn't do us much good. So the first part of our code is just the basic variables declaring all of the numerous pins we have going on here. So as we move through, we decided to make things easier on ourselves, and rather than make this all into one gigantic function, we just put a couple functions into the void loop. In fact, we even have a couple functions within functions. So here, I'll see if we can make this work so that you can see this. But basically, we have a reset function, a difficulty function, and then it goes into a while loop where it checks, where it'll run it until user wins or computer wins reaches 3. And it'll go through and play the game 3 times without, well, 3 times or however many times it takes depending on ties. It'll go through it that many times without resetting everything and re-choosing the difficulty. Other than that, it's a pretty standard way of doing it. We do call functions within functions, which I thought was kind of fun. We have a read button function that'll then return values that are then assigned difficulty or rock, paper, or scissors, depending on what it's being called by. And then the only other thing that we do is we read in the voltages directly from the buttons because of the circuit that Colin talked about earlier. So using that, that's how we're able to differentiate between the different choices from the buttons. Hope you like our RPS video and that you have a good day.